What is quality assurance QA? Quality assurance QA is a systematic process aimed at ensuring that a product or service meets specified requirements and quality standards. QA involves setting up processes, methodologies, and standards to prevent defects during the development phase and ensure the final product is reliable and of high quality. QA is proactive and focuses on process improvement to prevent issues before they occur. Key concepts in QA. 1. Process oriented. QA is about improving and managing processes to avoid problems. It is more about doing the right things rather than doing things right. 2. Standards and best practices. QA involves adhering to established standards and best practices, such as ISO 9001, CMMI, or Six Sigma. These standards help ensure that processes are consistent and controlled. 3. Continuous improvement. QA focuses on continuous improvement of processes. Techniques like Plan, Do, Check, Act, PDCA, are used to identify areas of improvement and implement changes. 4. Documentation. QA involves creating and maintaining detailed documentation. This includes test plans, test cases, and other procedural documents that guide the testing and development process. 5. Reviews and audits. QA processes include regular reviews and audits to ensure that standards are being followed and that the product is progressing as planned. What is software testing? Software testing is a process of evaluating a software application to ensure that it functions as expected, is free of defects, and meets the specified requirements. Unlike QA, which focuses on process, software testing is product-oriented. Testing involves executing the software in a controlled environment to identify bugs, errors, or other issues. Key concepts in software testing. 1. Verification and validation. Verification ensures the software meets the requirements and design specifications. Validation ensures the software meets the needs and expectations of the user. 2. Test levels. Unit testing, testing individual components or modules of the software. Integration testing, testing combined modules to ensure they work together. System testing, testing the complete system to verify it meets the requirements. Acceptance testing, testing the software in a real-world environment to see if it meets the user's needs. 3. Test types, functional testing, ensuring the software's functions work according to the requirements. Non-functional testing, evaluating aspects like performance, usability, reliability, etc. Regression testing, ensuring that new changes don't break existing functionality. Smoke testing, a quick check to see if the most crucial functions of the software work. Sanity testing, a more focused check on specific functionality after changes have been made. 4. Test methods, manual testing. Testers manually execute test cases without automation tools. Automated testing, using tools and scripts to automate test case execution, making it faster and more reliable. 5. Test artifacts, test plan, a document that outlines the scope, approach, resources, and schedule for testing activities. Test case, a set of conditions and steps used to determine if a software feature works as expected. Test script, a script used in automated testing to execute test cases. Test report, a summary of testing activities, including test cases executed, defects found, and overall quality assessment. The relationship between QA and software testing. QA and software testing are complementary. QA focuses on setting up the right processes to prevent defects, while software testing is about finding and fixing defects in the product. QA ensures that the software development process is efficient and meets quality standards, whereas testing ensures that the final product is defect-free and meets user requirements. Real-life use cases and examples. 1. QA in e-commerce development. Imagine an e-commerce company developing a new website. QA would involve setting up processes to ensure that each feature, from user login to payment processing, is developed according to standards. The QA team might use code reviews, documentation standards, and regular audits to ensure the process is followed. Real-life example. Amazon's development process likely involves rigorous QA practices to ensure that every new feature, such as the recommendation engine, performs well under various conditions. 2. Software testing and mobile app development. Suppose a company is developing a mobile app for online banking. Software testing would involve writing test cases to ensure that all features, like transferring funds or viewing account balances, work correctly. Testing might include functional testing to ensure transactions are processed correctly and security testing to ensure sensitive data is protected. Real life example: a banking app like PayPal undergoes extensive testing to ensure that all transactions are secure and that the app functions smoothly across various devices. 3. Continuous improvement in a SaaS product. For a SaaS, software as a service product, QA might involve implementing continuous integration and continuous deployment (CI/CD) pipelines. This ensures that new updates are automatically tested and deployed with minimal risk of introducing defects. Real life example: GitHub, as a SaaS product, might use CI/CD pipelines to ensure that new features or updates are tested and deployed efficiently, with automated testing as part of the QA process. Summary: QA, quality assurance, is focused on ensuring that the processes used to manage and create deliverables are effective and efficient. Software testing is focused on ensuring that the product meets its requirements and is free of defects. Both QA and software testing are essential components of a comprehensive quality management system. While QA works to prevent defects, software testing works to find and fix them. Together, they help ensure that the final product is of high quality and meets the needs of the users.